Okay, to save some time, I've downloaded some data for the S&P 500 and for the company Apple. You can see their ticker here is AAPL. SP 500 stands for the S&P 500, and I've downloaded this data from Yahoo Finance. Also in this video, you'll need the data analysis toolpath. So on the tools ribbon, you'll see analysis, data analysis, toolpath. If you do not have this showing up on your version of Excel, revert back to D2L and you'll see videos for how to download data on Yahoo or Google, as well as how to install the data analysis toolpath. Alright, so let's move forward. Our overall goal here is to calculate the expected return for the going year. The first thing we have to do are calculate returns for the S&P 500 and for Apple. So we'll simply type in equal sign natural log, and we'll take today divided by the prior day. Notice that the data here are ordered newest to oldest. Hence that's why we're dividing today by the prior day. If your data are ordered the other way, you can either use the sort filter function in Excel, which is located on the home page right here. So it's a sort filter, custom sort filter. You would select columns A, B, and C, and then of course filter by or sort by whatever column of interest being date, and then sort on values, and then you do newest to oldest. So we're now going to fill in that area, and next thing we need to do is fill this data down. Now notice our 1 year ends at 252. If we minus 1, we're at 251, and our first row in Excel is our headers or our variable labels. So we actually have 250 days of returns. You'll find when it comes to trading days in the year for equities, it's either going to be 250 or 252 trading days depending on the calendar of the year. In this case we have 250 days worth of returns. If we drag down any further, we don't have data for Apple, so it's 0. We also have 2 more years of data for the S&P 500, and I'll show you one in a moment. So we're going to drag this down and fill in all the way. Notice our data ends at 754 for the S&P 500. Okay, so to calculate a cap-in value of expected return, we need to have a risk-free rate. You can go to something like Treasury Direct or look on Yahoo Finance, and we're just going to say the current risk-free rate is 1.6%. Now how do we find beta? Well, there's a couple different ways. We can divide the covariance by the variance, and we'd simply do that by entering an equal sign and then applying the function covariance by covar. Our first array is going to be the data from E2 through E251, so 1 year's worth of returns, and F2 through F251. The next part here is tricky. You need to know which variance to apply. If you start typing in var in Excel, you might get var, var p, var a, var.p, var.s, and you need to know basically, do you want to apply the variance of the sample or the population? Here we're going to tell Excel population. If we do sample, we get a slightly different number from the different methods that we're going to use going forward to find for beta. So we're going to take the variance of the market, which is the S&P 500, so E2 through E251 in this case. So that's the first way to find beta. The second way to find beta is to use the slope function. We'll type in an equal sign slope. And so now the slope is giving us an indication of basically a regression. For those of you who've done regression, this will make sense in a moment. Just to explain slope though is probably going to take more time than what it's worth. What we're essentially saying is what we know, what we're trying to use to predict it. So we know what the returns are for Apple. we're trying to use the returns of the S&P or the market to predict the returns of Apple. So our known y's, that's what we're trying to explain, is F2 through F251, and we're trying to use market returns to predict the returns of Apple. So you can see we've got virtually the same value here and here, just a rounding error. If we decrease the number of decimal points, now you can see we're identical. Lastly, to perform a regression, we're going to click on the Data tab, go to Data Analysis, select Regression, click OK. We're going to select an output range of P2. If you click labels, it will actually change the way the regression output, and you won't get the same value as slope, and you do not want to select constant as 0. So you just want an input range where we have Apple stock, that's what we're trying to explain, and we're using market returns to explain. You'll see the beta right here for x variable 1, and you'll see it's the same as n as well as in. That is using the slope function in n, and in column L, the covariance divided by the variance of the population. Just so you guys understand, really going back, if we were to take the covariance of the market and instead we don't use the variance of the population, but we just use the sample variance, our number is going to vary slightly. So if you get a number that's slightly different, it's probably due to the fact that you employed the variance of the sample and not the variance of the population. So now we know what beta is. Beta, right there. Next we need to calculate a return to the market. So we're going to use our historic returns as an assumption that those returns will carry forward. So we can say our price today, which is B2, and remember our last cell was B754. And lastly, we're going to subtract 1. So this 0.3218 is giving us the market return, but notice it's over a 3-year period. So we actually need to adjust this so we're annualizing the return. In order to do that, I say 1 plus this annualized return to the power of 1 divided by 3, and if it was 4 years, we just do 1 divided by 4, so the inverse, and then we need to subtract a 1. Oops. There we go. There's the error. Okay. So our annualized return, notice here the parentheses are important. We need to first solve for the return over the 3-year period, and then we add 1 to it so we can take it to the power of 1/3. So we need a value greater than 1, because if we do to a value less than 1, it'll go small. And then we need to back out our 1 after we found the annualized amount. And we can double check this amount by simply saying 1 plus our return to the power of 3, and then we'll subtract 1. And so you can see we end up with the original starting amount. And we can just double check that by saying B2 divided by B754 minus 1. So you can see we're getting to the same place. So in fact, 9.7% is the average return for the past 3 years. Average average annual return. So now we have the risk-free rate. We've solved for beta. We have a beta of 0.4, and we have a return to the market of approximately 9.7%. So we're next going to use the security market line formula, or the CAPM formula, to solve for an expected return for Apple year going forward. So we know it's equal to the risk-free rate plus beta times the return in the market less the risk-free rate. And so the return going forward for Apple, we should expect a return of 4.85%. Now, for some of you, this may seem rather small. You're thinking, wow, why is this so small? Well, let's look at the market risk premium. So here's our expected return for Apple. So remember, the market risk premium is equal to the return in the market less the risk-free. So what we're now saying is, in terms of market risk, when Apple has a beta of 0.4, it gets market return premium of 3.25%. So just over 3.25% of the return going or attributed to Apple is due to market risk, and the remaining 1.6 is risk-free. So we can see the risk-free return is equal to this 1.6, and then we add these together. You can see that's the total return to Apple. So it's clear what we're doing here. We're saying that the return to Apple is a combination of market risk and risk-free return. Apple gets 1.6% of risk-free return, and the remaining 3.25% is due to the market risk that Apple faces once it's a part of a well-diversified portfolio. Hopefully that answers all your questions. Again, remember, we can find beta in at least 3 different ways. We can divide the covariance by the variance of the population. We can use the slope function, or we can perform a regression. And within the regression, it's your coefficient for your x. That is, you're using market returns to predict the returns of Apple. And in this case, we see it as the